Electricity did come down. So July, he invites all the fancy people like you guys down here, and he flips a switch on that piece of marble behind you. And then when that happened, 3,500 volts of AC, alternating current, flowed down 2 parallel square copper wires, uninsulated.
Wow.
Yeah, down into this mill. And when it did, an AC induction motor, similar to that one, that's the replacement after the fire, started to turn. And when it did, he's a hero. He's no longer a fool. Well, very soon after that, he was recruited out to go to other gold plants in the world. He never came back here. And he probably had enough of being, told he was an idiot. So the original motor was single phase. AC, which meant you had this light bulb on the top, and you had to have a telephone to where, from your here to where the AC power is generated, which was 12.5 miles in Green Creek. And you had to synchronize it using the phone so that the blinking of the light here was the same as the blinking of the light up there, and then your motor would go.
Wow.
Yeah, it's just, I mean, we never think about this stuff anymore, But this was a multi-phase motor later on, and they didn't have to have the blinking light. And we had 3,500 volts. We dropped about 500 on the way down. And that's what Nikola Tesla would have expected. Because, Nikola Tesla was in this huge discussion, well, it was more than a discussion, with Edison. And Edison was a proponent of direct current. All the electrons go one way. And Tesla said, no, the best thing to send a lot of voltage down the line is alternating current. It goes this way, that way, and then it reverses and goes back that way. Turned out Tesla was right at the time, though now DC is a way that they send huge amounts of voltage, especially like in the Four Corners. But in the meantime, Tesla was the winner of that debate, and they hated each other, apparently. So anyway, AC current is really good for a lot of things, but some things it is not good for. Like your lights. When you flip the light switch, unless you got a fluorescent, a government-approved fluorescent, the light goes on right away. And our hoisting motors for up the hill were little trolley motors that were recycled from San Francisco because we're green, And so a motor, what happens if a motor starts slowly? There must be some.
It can burn out.
Exactly. So we need power right away to get it going full speed. So we needed to make our direct current here. So they just hooked up a belt from there to this big DC generator, and we had all the direct current that we needed in our mill too. So we were in good shape. Well, that July was one of the first long-distance transmissions of alternating current ever. Right here in this mill for $38,000. Got rid of the firewood, didn't need it anymore. So this is, again, a place where innovation happened right here in this mill. And for the people who like to take photographs, I like to point out that transformer.
Oh, they got it.
Oh, yeah. All right.
Awesome.
Nikola Tesla patented that. Did you know that? He patented that when Tesla was patenting for Westinghouse at the time. And that's a transformer. It steps the power down from a higher voltage to a lower voltage. And Tesla invented and patented that in 1888, and we bought it used in 1893, because we're green, right? Before we knew we were. Anyway, I just love that piece of equipment. So let's go to the machine room, because that's where you guys are going to have the favorite thing. All right, so this machine room wasn't there in the original mill, but they were smart enough when they rebuilt it over the winter of 1898 to 99, they put in a machine room. And this machine room is a dangerous place to work because all of our machines were all on all the time. You will never find an on and off switch on any of these machines. That's why I go OSHA would just have a heart attack.
These are all electric? Or
No, they're run by belts.
oh,
Because
okay.
all this was belts and pulleys, and the speed even was governed by belts. So we had our engines in there, a motor in there, and it was moving all these belts throughout the whole mill, whether it's the stamps or this or anything else.
So electricity came before
Yes.
after they rebuilt the mill, right?
Before.
Before they rebuilt the mill. So it was an old
yes.
mill, electricity?
The old mill just used steam power. The boilers are down there. I don't know if anybody wants to take a picture of that. And they're all covered with asbestos, which is another reason why we don't let you go down there. But it was all steam. It was steam power up until until the electricity came in. Excuse me, in 1890. I'm backwards. Excuse me, I'm backwards. 92, 93. That's when we had electricity. You're right. I'm backwards. And the burning was 5 years later. The mill burned 5 years later.
Okay, so they had already converted it to electric.
Correct,
And
but
it burned.
at times, I mean, they still did use it because again, you know, our water supply is kind of erratic here on the Eastern Sierra. So sometimes they'd have to go back to the steam boilers. That's why they never took them out. Yeah. Alrighty.
Backup system.
Yeah, exactly. So this room is not really innovative or anything like that. They just put it in because frankly, you know, we didn't have Amazon then. If we needed a new part, we would just be better off to make it here. Yeah. I was at a gold mine on Sado Island in Japan. The shoguns operated it and financed their operations with gold and used captured Koreans and homeless people to work the mine. But anyway, when the shoguns sold it to Mitsubishi Heavy Industries around the turn of the century, their machine room was exactly similar to this. It was
Really?
kind of around the turn of the century. It was pretty amazing. So while this isn't innovative, it did cut costs. So we obviously, you guys all know what that is, right? Drill press?
Drill press.
Okay, behind the gentleman with the gray shirt, what's that thing?
Oh, he's down the bench.
Well, I know that.
That's a grinder.
Yeah, and what happens when we grind metal?
Sparks.
Oh, yeah. And, okay, so then we have a machine shaper. This is kind of a fun piece of equipment. Sometimes we had to cast things and make in molds and make new parts like this bearing housing. And after we cast a new piece of equipment, sometimes they'd have sharp edges. So this thing had a blade that went like that, and you might want to smooth that. Huh?
Buffed them.
Buff it out, yeah, exactly. So we do that. Now, of course, when you're putting your piece of metal, whatever, through here, it's creating a nice red-hot curly cue of metal, right?
Yeah.
If you worked in this room, you had to be a machinist, and you get $5 a day. Yeah,
$12 a day.
pretty good.
Specialized skill.
Specialized. And if you didn't have any business in here, you were not allowed in here because it was so dangerous. We had sparks flying from here. We had oil vaporizing. We had metal coming from here. We had a drill press that was, you know, the speed of our machines. You could change it by moving this belt on the wedding ring. There was clutches up there. Yeah, there's clutches up there. I know, it's crazy. And did we wear protective eyewear or clothing? No, it's most unmanly, of course not.
Shorts and flip-flops.
Yeah, yeah. And was the company required to give this to us? No, cut it into profits.
Look at your own risk.
Yeah, you know, there was a Supreme Court decision in the middle 1880s, and it held that, let's say I'm the owner of the mill, which wouldn't be true, but I'm telling you that a particular activity is very dangerous, and you hurt yourself doing that. It's your fault. I told you, I'm not responsible.
Don't do it again.
Yeah. We'll find 8 people who want your job. Anyway, this is really cool. This is a 24-foot long lathe. Yeah, at one time it was one of the biggest lathes on the Pacific coast, and they brought it in 2 pieces from the east, from Hawthorne, Nevada, and before that from Reno, with about 20 mules on freight wagons. This thing is really heavy. And
20 mules? I don't want to be one of those mules.
yeah, but you had a heated barn here.
I said I wouldn't want to be one of the mules.
Oh, yeah, you would, because your barn was heated. I mean, you always had a warm place to stay in the winter. Remember, 40 degrees below zero? But I know what you're saying. I wouldn't want to be a mule either. Okay, let's go. Oh, that wasn't to heat I had a machinist the other day tell me, this was not to heat up the metal, this was just to stay warm. Because you know why you can tell that? Because look how thin that is. They just probably put firewood in here and on the bricks. They had a blacksmith shop over there, and that blacksmith got $6 an hour. And my guess is the blacksmith shop is where they would heat all that up. Right. So, the average man was 5'6". The average.
So short.
Yeah, I know, 7 feet doors, doesn't make you crazy. And so this is here is where the motor had a belt on it, and the belt was went to the main drive wheel of the mill. This was it. So like if you guys, especially the tall guy there, I mean if he was walking up here, he definitely wanted to duck because this belt was just going all the time. So you can. Wow. Yeah. And one year this is off the script. Well, there's no script. Anyway, but one year, a couple of people were reopening the mill at Memorial Day. That's usually the start of our season. And they open the door, they come in that way, and they see underneath here a female mountain lion with 2 cubs. And they're like, I think we'll just sort of back out of here. And so they called Fish and Game and said, what are we supposed to do about this? And they said, oh, just play music, she'll leave. And 2 days later, they saw her with 2 cubs leaving. I mean, she didn't have her hands over ears or anything, but that made her leave. But now they always have 2 people opening up this mill in whenever the first part of the year. But this is a great place to have your cubs. Wow. So come on down here and take a look at the size of the timbers. These are all different kind of timbers. I can just tell the first where this metal. I'll step. Yeah, this is where the photographer starts to get good.
My grandfather modified it.
Yeah.
Really?
Probably has Barry Manilow on it. I know, I hate this thing here. One of the park aides likes to play this noise and it goes talk, 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 and I think it's really annoying, so I don't play it. Anyway, this is where the small pieces of ore came down from the top floor and they went into the back of the mortar box here, and this device rolled everything around so it all went in evenly. But we used a lot of gravity in our mill, so some people like to take pictures of that, and they can. Now watch out, this is where the steps get crazy.
How big these are?
So some of you can come along here, and some of you can go up there. You guys doing okay? Are you okay? Oh, I know where. Oh, my uncle and my aunt had a grapefruit orchards out there. The Gliders.
Yeah, we ran them out there.
My uncle was very good
There?
in his liquor store. No, he was murdered in Etiwanda. Guy out of prison 3 weeks on a prior 7 years.
Dangerous room.
Well, this was. Okay, I'm going to start talking. It's okay. You can keep taking pictures. All right. So here we are. This is where it all happened. This is the Amalgamation Room. Here is where we amalgamate gold and silver with mercury. $4 a day. So the first thing we have to do is understand what's going to go on. The stamps are going to go up and down in the mortar box. Water and ore will be introduced, and they'll go up and down, pound away. And they will pound away with water till every piece of ore in there is really, really tiny. It has to be so tiny that it has to pass through this screen, which we took off the front to show you how the stamps are uneven. But if you can see in the light here, look how tiny the holes are. That's what they call 40 mesh. That's 40 holes this way, 1 inch, 40 holes an inch that way, da, 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 da. Nobody screens doors like this. And in order to exit from our mortar box, you have to be a little piece of ore that tiny. That's why I was saying the stuff that we wanted to, can you see in there?
Yes, ma'am.
Was like face powder, like flour. I mean, it was just so fine. And the reason we did that is what we were trying to do is as the slurry of water and rock ran down these amalgamation tables, the particles had to be very, very tiny in order to for the mercury to amalgamate. And so I'm going to put this down because I can't talk upside down. Before we start our stamps, though, we have to prepare our amalgamation tables. That's what I'm standing on. Originally, our stamp mill had 4 batteries of 5 stamps, so this mill was a 20 stamp mill. And that's how people, when they say, oh, your mill was 30 stamp, yours was 10, whatever, that's how they would categorize them. All right, we got to get our amalgamation tables ready. And what we have to do is we have to get them covered with mercury. So as the slurry runs its way down, the mercury will grab the gold and silver, let the rest go out the front. So the first thing, our amalgamation tables use gravity, and all the tables had copper plates on them. This is the only one that's left. Now we've got to get the tables ready to accept the gold and silver, to amalgamate it. So we take a bucket of mercury, copper bristle brush, because see, mercury likes copper, and that's copper. So we just do a little house painting, like that. We paint all of our copper plates with mercury. Now we want to be sure that all of our mercury actually adheres to the copper plates. So we just pat it down and make it look real nice. All right. Then we start the stamps. They start pounding away. And either 30 minutes later or 3 hours, depending on how rich our ore is, we have all the tables covered with mercury have now turned this really ugly gray color, like lumpy gray oatmeal. And what's happened is the mercury has amalgamated. And what amalgamation is, sucking it in. So the gold and silver becomes part of the mercury, like your silver amalgam fillings. Yeah. And so after a while, it's starting to look really lumpy and just ugly. Foreman comes out of there. He takes a look and says, well, you know, to try and decide whether or not that the mercury that we have on their plates can absorb any more gold and silver. One way is to just put your finger in and see how it feels, but another's just looking at it. So after a while, he says, okay, that's it. And what they do then is they take this extremely high-tech scraping tool, and we scrape all the mercury down, and push it into the corner, and then when we do, we roll it up in a ball with our hands. Gold and silver in mercury. We take it and we put it in that safe, and the people who do photography, the professionals, are always taking pictures of that, and they don't know why, but it seems like they always, so you guys should pay attention to do that later. All right, anyway, we had it in the safe, and when the foreman says, okay, we can't, the safe just doesn't have any more room for gold and silver and mercury, it's called, that's called amalgam. The word, you know, have you heard the word amalgam?
Yes.
Yeah. Well, that's amalgam, is gold and silver with mercury. So then he says, okay, let's take the buckets of the balls of this mercury and we'll put it in a really tightly fitted oven and we'll heat it up. And of course, you know, mercury boils at a very low temperature. So we'll just heat it up. When it heats up, the mercury turns into a vapor. The gold drops down out of the mercury. And then the mercury hits the top of the oven and then it goes out a long tube, which is covered with a jacket of cold water. Yeah, we're making whiskey, but we're basically distilling it. The vapor hits that cold surface, condenses into a liquid, comes down and drips into a pan, and we reuse it because, you know, we recycle here. So mercury's also expensive. So that's one way of doing it. Okay, so we've got all our gold and silver and stuff, and we pulled our mercury off. But you know, this process only yields 60 to 65% out of the total gold and silver that we know is in our ore. So we're going to have to do something about that return because it's simply not acceptable over time.
Efficient enough.
What's that?
Not efficient enough.
But they use this for a long time in the absence of any other ideas. So now people are wondering, what if I work here in this room? How about the noise? Remember, you can hear these stamps 20 miles away, 3 miles away?
You don't hear it anymore because you're deaf.
Right, but what we do is we might tell you to go down to the Boone store and you could buy some beeswax and stick it in your ears. Now you don't want to go out in the heat because beeswax melts at a fairly low temperature, so then it just goes in your ear canal and that's the end of that. But what they did use here apparently was a lot of hand signals because the noise was so loud and you just did not want to lose your hearing. People say, how many people died from mercury poisoning?
0.
It wasn't an entry on a death certificate. However, let's say you worked in this here. You might be able to work for many, many years. Your kids might be able to work here. He's working here for 4 months, and his fingernails are falling out and turning black. He's losing all his body hair. His teeth are falling out. He knows it's time to move on, right? So we really don't quite understand what's the physiological mechanism of why you get sick and you don't. What we do know